Okay, today we will talk about the homework problem. It's due next week. So I'm going to talk a little bit. Just a second, let me make sure I have the right share. I think that's right. So to talk about the Catch Me If You Can, which is the homework problem. This is some demonstration of what is talking about for this good and a good idea of the homework, and this is also the benchmark that you need to beat. Just keep in mind, this is very important, and this notebook is already uploaded in the Brightspace, and I would suggest everyone to look into this and to as this like starting point of your homework. So this is something called web page session tracking. So this is very important because, and this is a very hot topic, web user identification. So basically what you can do is you can, using the user's click, how much time they spend in certain like website and what website they are using to determine which user, and using this pattern to do data mining and behavior psychology. So this is the task is using internet tracking, tracking or sequences of attended web pages. This algorithm is to take some like web page session, a sequence of web page attendance, and consequently by the same person, which is called Alice. I'm going to predict whether this sequence then belongs to Alice or not. So my target metric is and ROC AUC, we have talked about this. Basically, it's a binary classification problem, 0 or 1. So the training set has all the informations on the user browsing sessions, such as a site and a site ID. So the site ID only has an ID for now, but in fact it has a mapping that can map back to which website they are using. Let's see. Okay. So, that dictionary is site dic.pkl. The time, we have a timestamp of attending the corresponding site target. Whether this session belongs to Alice, one can use the an original data of training to form a training set that you can use this, because you don't actually need to using the original and data set directly. Okay, so we mount the data, we unzip the data, we read the data. Okay. So this is all pre-processing the data, and then let's look at this data here. So this is data. For example here, so, and this is session ID. And then that person has viewed site number 56, and starting on this time, and site on number 55 on this time, and site on number 56 again on this time, and so on, and site on number 5 and 55. So these are the viewing of the 4 sites. and the target, which is 0 set. So that means, training set tells you, and this person is not I'm Alice. So this is that session ID, and there are more session ID. It talks about like different sites and so on. You have all these data, and the total at most we have 10 sites and 10 times that. Okay, so this is all recorded right here, and you have a testing data set. Testing data set right here. You don't have any target predictions. So basically, that's the data you actually need to predict for it, right? So, so this is the point of the targets, and so sorry that that's the point of testing data set. So the testing data set don't provide any kind of target, and the values you need to save the target values and based on your models. Okay, so first thing that we need to do is we need to fill in and so these sites values, which and these and transform and the data that format can be fed into counter-vectorize. So if you actually look those text and data that we have, and the site data that we have, that's basically like an integer float. So basically you cannot do kind of an histogram. So I want to see like how many and how frequent of that person visit those like website. So this is the first thing that I did. We transformed all the data of the site into the format of integer. So it won't have like the .0 here. So this actually give you the float. Float will cause some problem. All right, so that's good. If we do this, you will find out my training test site looks like this. So basically, every NA data becomes 0. Everything else just becomes an integer. Okay, so this is not float. This is just purely integer. So basically, we can do like a bin count for all these like sites like directly. So so we can do these kind of count and vectorize. And if you remember, we're using this kind of thing in backwards. So this is basically the same thing if we treat, so each like different site ID as being like a word, right? So we want to count how many times they have visited that specific site. And of course, at this point, we don't know and what does this ID relate to which site, because that's saved in a different file. We might using this data if we need it later on. Okay, so if we run this, so that's I'm going to. So this is and using the okay, so we have and using 1 to 3 gram like, and the unigram bigram 3 grams. So sorry, I will using the unigram and bigram in this cases, I think. And the maximum feature is 50,000. So that means I only want to using and getting 50,000. That's the maximum that we're going to get. So I'm going to using this and CV like counter vectorize to transform my training file and the testing files. Okay. So basically, this is I'm only using these data here. I don't care about the time right here. I only care about and the visit and the visit site ID, and in this case is 29, 35, and so on. I only using this information, trying to make any kind of predictions, right? So this is we're only using partial data for now. And of course, as we expected, if we're only using partial data, then the result will not be as good as we're using full data. But I mean, so using full data, that means we need to process things more. You're going to do it in the homework. But this just give you some idea and heads up. So I mean, if we do this, we got a training data. We know this is a lot of entries. We have and 253,000 rows and 50,000 features. So that's like that amount of like features that we got. I mean, so everything is stored in a sparse matrix. So as we expected. So, and this is very important because we have mentioned, I mean, if you want to turn this into full matrix, that would be ridiculously memory intense. So this makes whole things much easier to and to handle. All right, so this is something. Okay, let's see the train. Save the train target. Okay, so we also need to put the target into a separate vector, right? Because I don't want to put this as a feature, so it doesn't make any sense. There are several. So one thing I have talked about, if we're talking about as a timestamp, it's very important that you don't do reshuffle, right, of your data. If the data has a timestamp, and particularly, and you think the time will have a strong impact to your and to your models. So that means what you can only do is you can only do time series cross validations. So that means, I mean, the previous way what we do cross validations, we are using this part, these two parts, our training, and the test on the testing data set on this. This is not possible, or is strongly against during the time series analysis, time series cross validation, because you are using the future data to predict the past, which is not realistic. So what we can do, as I mentioned, you can do time series split, which is the following. So you have the data and you sort it along the times stamp as and we did on the first thing we already do. We saw the values based on time one. So basically this is all from like and the beginning to the end, right? So it's and chronicle. So what you do is using, say, this portion of training to do this testing. You just leave everything out. We're not using this at all. Then you gradually expand and expand your training data a little bit. Then you're moving your testing data set a little bit. This to ensure that always you are using past data to predict the present, and you are not using any information from the future to predict the current data set, right? So, and this can be done using this time series cross validation. Scikit-learn time series split did very well. Okay, so you can see how this is and all these shapes. So in each and in each split, and you can see my my test is being the same size, and my training has started to grow gradually. Okay, so I have a 10 split, but previously here I'm only using, say, once and the same size as testing on training, then we predict on testing, then we gradually grow our training set. But just ensure everything are in the same page. So So we just using past data to predict the futures. All right, so here is good. Okay, so and what we can do is we have this kind of cross validations, and but in this case is I mean, if we want to using cross validation score, which if you call like CV equal to 10, then just automatically it will create like tenfold cross validation. So what we're going to do is going to input CV equal to time split that you just created from the scikit-learn time series split. So I mean that you force the scikit-learn to using your own time split cross validations. So you have a logistic regressions. You have your logistic regressions with just default parameters equal to 1. You have a legit, you have an X train, you have a Y train. You provide your time split. You provide ROC AUC, which is the scoring system that we do. You have n job equal to -1, which is we using parallel as use parallel as possible. So let's see how long does it take to run. Okay, after 45 seconds, it's finished running. So you can see this CV scores and the mean of CV scores. So you can see these cross validation scores varies a lot from the lowest 65 to the highest of 96. So you can see the variance is pretty high. On average, we are getting about 86.8% of accuracy. And to remind you, we're just using part of data. We are not using the full data and the full information of the data yet. So we can do the whole fit. So basically, that's your training data. And and we can make predictions. And this is the prediction probability. So this is basically is the probability for this prediction data that being Alice. What is the probability for that specific and the rows being I mean Alice is viewing that website. Of course, we didn't do any kind of hyperparameter tuning, which is not ideal, but what we can do is we can do this hyperparameter tuning. So and we can do this kind of like hyperparameter tuning directly. So and of course, so this will take a lot of time to do. And let's just, for the sake of time, that we just don't do 10 times split, which is and a lot of time. So let's just do three times split. That will make things less expensive. That's good. And I don't want to steer the screen for a long time. And let's just do log space of 5. That means we only need to do this 5 times 3 times because it's threefold in time split and 5 different C parameters. See how long does it take for that. And hopefully it will be faster. Okay, so I mean, let me just So I mean, so once it's running, so and let it just run a little bit. So this is basically, you can, from this, you can find out the best parameter and the best score. So this is all your baseline. Basically, we only using these site numbers. We didn't use any kind of other information of the site, right? So it's very limited information. We are getting 87% of validation error, which is okay. I think it's unreasonable. That means we have still has something to do in terms of improvement. The second base things that we can do is we can start with the basic site features and apply the bag of words features. So still running here. So basically what you can do is you can get everything and read the site from the ID mapping, provide this and the data. So it's all in the site and dic.pkl. So this is the file already. I think I already download that. It takes too long time to run. So let me just cut it. I mean, it's right here. I think we already downloaded that data right here, right? So it's right here, site.dic.pkl. So we can using this information if we need. So basically, so all these site and ID corresponding to some URL, and this URL could be very useful, could be very meaningful in terms of to perform any kind of machine learning and predictions. So we basically, if we run these things, we get and again, a sparse train and test matrix and vector of the target, which is just 0 and 1s again. And but this time, we got a TF IDF vector. We will have this site names information into this, and site visit time, both for the training and the testing side. So you can do some feature engineering to that if we need it. So you can see this is the site and X-train, it's the same thing. But the difference is here is those vectorized here is no longer just ID. It actually has the URL. So you can see, for example, this guy is viewing the docs.google.com. So you can do like, say, different one. Let's just say 100 to 110 and what are other like URL. So this is drive.google.com and so on. Okay. So this is all like Twitter or different things. So basically, we are not just viewing those IDs. We actually have some idea what those like URL they are viewing. So because ID and versus ID, we only know they are viewing two different sites, but we didn't know how close of these two different sites. But once we see the URL, we know, for example, this URL is close to this URL, right? So because they are very similar. So that means, we can just have some idea if someone is viewing this, it might be likely they are viewing this as well. So this is some put additional measure on the differences on different IDs. So we have additional informations that we can use. Again, we can do this cross validation. Let's just do 3. And let's see how long it take for this. I think this will be quick. Okay, so that's good. You can see this cross validation mean you're getting an 80, 79, 88, 89, on average 85. Right, so this is basically And what we did, and before we didn't like, and we didn't, and using all the information yet, right? So this is basically all the training sessions that we have. Right, so this is nothing, and like nothing special yet. And I haven't, so sorry, we just applied this like, and everything into this vectorized TF-IDF, like vectorize it into this X string and X test. So this is being, I mean, a little bit richer informations than just the, like the, I mean, so like ID numbers. All right, so of course we only do 10 of that. So this, and give you some like result, and we can do the whole train together. It would take a bit while. And the most important thing is if you're using this LE5, it can actually display the model weight. So basically this is give you the model weight of top 30 in different things. So you have, this is like more negative one. So this is more positive one. So what does that mean? If someone is viewing the plus.google.com, it's very unlikely to be Alice. If someone is viewing uwatch.org, it's very likely to be the Alice, and so on. So this is basically sees if someone is viewing these like website, it's more likely to be Alice than someone viewing these sites. So this just give you what does that mean for those weight. Okay, so, and obviously it's a good idea to write a separate function that we don't need to repeat these things again. So this is basically a function that we can use. This, I think I ask you to do in future of homework, is always write like these kind of train and predicting functions before ahead, so that you can use these kind of functions again during your training and the predictions. Okay, so then you don't need to rerun these things and rewrite these things again. So this is very important. So if we do this, it's basically you say, okay, I have my model, I have my training data, I have a Y training data, I have a testing data, I have a feature name. So these are the feature names that I have. Then you're using cross validations and just run. So all you need to do is you change different models. It will automatically create these and a cross validation scores and means, and all these weight explicit. All right, so this is very important. All right, so, and of course here we haven't done any kind of the, for this, I mean, particular part, I didn't do hyperparameter tuning for C. You can also do that if you want. This will boost up the and the accuracy a little bit. Okay, so and of course, right now we're just using these site information, site 1, site 2, site 3. We haven't using any like time information, which time information is also very important. We are missing right here. And also, we want to come up with some like correct time feature through the EDA. I mean, that means it's, so exploratory data analysis. So basically we need to do feature engineering to understand the data, such that you can and find out what is the best way to cooperate these time features. So, and then that means, homework you also, and you need to do any of these and these kind of things to understand the data. In fact, once you have like all sorts of like realistic data set, these type of things shows up again, again. So one of intuition that we got before we even like know this kind of problem is different people might prefer to visit even the same sites at different time of the day. And for example, people will probably open the Gmail in the daytime because it's working time. So at night, people will like visit the Netflix and to watch them like movie. So okay, so let's see the train time one, which is the first time then they click that the first site, right? So this is the site. So we can just extract the hour. I think we did something like this in my homework. So basically you have the timestamp and you get rid of everything else, just extract the hours. Okay, so hours is very important. Hours can give you a very good information. So if you do the counter plot, you can see this has very significant deviations, right? So you can see right here, this is very like, and a little behavior here. And we see the information that from so midnight to 6 a.m., there's no information, but there be and a very interesting trend, and there's a big dip at noon. It could be like lunch hour, so that's why there's a dip. Okay, we can do more plot to see the different trend for Alice. For those zero, that means it's nearly the same trend that we have. It's like basically very low activities at night, and like has fairly high activities at right here, second peak here. So on the other hand, Alice is doing very different. So Alice preferred to viewing like and browsing at 4 to 5, and sometimes has like second peak around 12 and 13 at noon. So it might be a good idea to create a feature of a morning, day, evening, and a night, right? So you can separate these kind of informations. So everything here will be morning. Everything here will be day. Everything here will be evening. The rest will be night. Okay. So do something like this. That we can get across that. Okay, so you can see right here. So we have no data from night. In the evening, I think in the day we have more data here, right? So and we have a significant amount of data here. For morning we have a fewer data here, right? In the evening there, so there's basically no data here because after 7 p.m. it stopped like browsing any kind of activity here. Okay, so what we can do is we can add this new feature into this morning, day, evening, night. So these are the 4 additional features based on the time. All right, so we can adding the features. So now I think our X train should have 50,004, right? So, oh, did I have additional? Yes. Yeah, with the training one. Okay, so this should be like this, 5, right? So we have like additional features to be added. Okay, so we're adding the time information with morning, day, evening, and at night, and all these and new features to be added in. Then we find out we have an additional information. Oh, and And so I also add hours as well. So hours, morning, day, evening, and night. So 5 features, sorry. So you can see right here, my cross-validation being significantly boosted from 86% to 0.86 to 0.93, right? Significantly better. And you can see right here, this hour this has a very strong weight to it, and evening has a very strong like negative weight right here. So you can see morning has a negative weight, and day a slightly negative, evening has strong negative, and hour is very strong positive, right? So if you check and you can see this has like significant improvement of all the fold compared to the result from the previous cross validations. Okay. So let's try the result without the hour. So we have seen a very strong weight on the hour. And then let's see, like we can manipulate things a little bit, because from hour we can, determine whether it's a morning, day, night, or evening. But the other way around is not possible. So let's get rid of the hour and try it again. So we can see this is morning, day, evening. This is it's still better than the first one, but not as good as the last one. But if you do like 10 of this, you will find out different result, because a tenfold has much more like information than threefold. Just for the sake of time, I just did threefold. But if you do tenfold, you will find out previous one, if you're adding the hours and all these like days, nights, and the result is not very stable. It's like give you some like fluctuation stuff. But this give you much more intuitive ways, because we know during the day, it should give you a positive weight. In the morning, it should give you negative weight, and in the evening, it should give you negative weight, because Alice is mostly viewing and browsing during the day, right? So this is very important. So this is something that is very and a significant information puts in. But right here, in fact, the day is to give you negative values, which doesn't make much sense, right? So when you're proposing your algorithm or the models, so you also need to interpret. And otherwise, it's very hard. You're getting very good result. You didn't know how to interpret. And interpretation is very important. Here, it's very clear you should get a positive weight for the days. The reason that it didn't give you is just because I'm adding an hour here. It's just kind of like overfitting here. So that's why it's causing some problem here. So once I removed hour, this weight makes much more sense. We have a positive weight for the date. But if you do tenfold, you will see something. You will see this actually is better than with our features, because it will be more stable. It give you like less variance. So I would prefer this one, and rather than to add hours. So with the two reasons, this has less variances if you do tenfold, and also it's meaningful. It gives you like meaningful reasons on the weight for the days. We expect the weight for the day should be positive rather than negative. Okay. Also, and also we need to add a session duration, right? Because we need to view like how many time they spend on each website, so we can add this information to it. like how long does it take for that person to view that one session, right? It's maybe 2 minutes, maybe 5 minutes, and all these kind of information matters. So we're adding this, it's like session duration. Okay, so it's basically the maximum of the time for each row and the minimum time for each row. So basically subtract that and turn this into millisecond. So you stack all the information to this. We do this. And I show this is incorrect just because you can see the error drops significantly from almost 90% to 50, 60%, which is really bad. So something is not right. The reason, so we are adding like session duration as one like features. The reason is this new feature session duration is counted in the milliseconds. So the value is very high. So basically, if you check this feature right here, what is that? Maybe I just check this a little bit, okay? No. Oh, it's okay, COO. I can't even like do this, but that's fine. Because it's in like milliseconds, the value is very high, so you cannot get this values directly. So I mean, so the whole matrix, sparse matrix, you cannot slice easily. You can only slice in a very certain ways. But the beauty of sparse matrix, you can always plug and plug in a scikit-learn, you just do it by itself. It's very natural. Built in the scikit-learn packages. So you can check this out and to see what is the like train duration. So you can see this train duration has very high values, right? Like, and sometimes can be, as high as like almost like 1 million. Okay, so that's why it's a very a big problem. So we need to rescale it, and otherwise there are, different unit you cannot compare an apples and versus peer. So that's why we should rescale this feature and to make sure this is properly scaled in the way that we can handle it. So if we scale it like with standard scaler, and we have to talk about this, and stack the data, and this time with threefold, we're getting reasonably good result. 92.1, right? So it's pretty good. So you can see this session duration has relatively negative impact. So basically, the longer of the session duration that you have, basically and the less likely to be added, because added prefer the shorter sessions, like durations. Okay, let's see whether it gives me a better result. Out of 3, yes. All right, adding one more feature. So that means this feature is important, right? So once I added that feature, I'm getting better result, right? So better result, that means I'm going to keep this feature. So that's how you handle this kind of feature engineering problem. You're going to add in and base your idea and create the features and understand the features and test the features, whether this feature is useful or not. You need to let the data talk, right? So, and to understand this a lot. Okay. So we can try more complicated things. For example, we can add like say and more time features. For example, days a week, a month, and years a month. Right. So these are all so very important features we're going to add in. So, and always like, I mean, if you and find out like the features that you have, it's very important that you know and you know like and how to handle these time features. Sometimes you're just using the hours, sometimes you can using the month, sometimes you can using days a week. It depends on the problem. For example, the flight and data and days a week seems a very important feature, and also month seems a very important feature. Hours is also very important features. So these are all very important features, and we probably need to include that. But in this like internet tracking, hours seems a very important feature, but I'm not sure whether days a week or month and the years and these kind of things. It might not be relevant. So that's why you need to using this kind of EDA to determine whether there's a significantly statistical differences between Alice and others. Okay, so let's try to add these informations into days of weeks, month, and years of month. Okay, let's see whether it actually gives things better or not. Okay, so let's run this. So you can see the new feature that I add in, particularly for the years, the month has a very strong negative impact. So that means along the day, the years of month actually give some like negative features to and to have a negative impact for our prediction. So that means it has something. So that's good. Um, and of course, as everything that I do, I haven't do any kind of hyperparameter tuning, and you should do that. So once you have created all these kind of features, that you have done all these kind of like feature engineering, no more ideas, then you can fine tuning your hyperparameter. Don't fine tuning hyperparameter before ahead, such that this will waste a lot of time. You will make sure you are getting the right and the right feature first. Then you can do hyperparameter tuning. Then you can create like nice pipelines and do this like hyperparameter for a very long time. Um, uh, so you can choose like n-grams. You can, even choosing the maximum features if you want. Can choosing like different TF, IDF, vectorized things as a hyperparameter tuning. But the easiest way to do it is like just regularization strength, right? So this is C is the easiest way that I can do. I'm not going to do it. It will take a very long time to run. But after that, you can do some summarization for this. Okay. So this is very important to show you how to deal with this kind of data set and what is mindset and how to using these kind of informations from the raw data, and finally you create like some baseline models to start with. Okay, so this is basically the demonstration of this data set. So this has some baselines models that you want to beat, right? So I will expect you to come up with some better model to beat these things, and also this and another baseline, and I get you through as well. It's in the 93 over 2. The same thing, right? So this is exactly the same thing. So like visiting time and so on. Basically the same data set. So, and I have done simple and processing, right? I mean, this and the data is and processed very in a very naive way, but you still need to do more and processing if needed. So this is EDA, just give you her idea about and what is the maybe the differences between Alice versus the others. So you have some good idea to come up with the new features. So the first thing is we need to prepare the data. So in order to train the first model, we need to prepare the data, and we need to exclude, and of course we have to exclude the target data. So we get rid of the target data, and also we train, and the train and testing has the same columns. Then you can aggregate them into one and a data frame. So you and all this transformation will be, and you can perform at the same times on the training and testing if you want. So it's very important. But of course, I mean, it will take like a longer time. So and the one you can, I mean, this case is what you can do. I mean, so you can like train your models, and you train everything that you want, and do and all these kind of transformation and apply to testing data set. That's also perfectly fine. So I did some like very simple so processing. So give like very simple idea for that. And also for this very basic model, we were only using the visit at a website as what we did. So, and that means we're not taking into account of timestamp features, but you should consider the timestamp features later. The point behind the data set and selection is if Alice has her favorite sites, the more often you see these sites in session, that means should have a higher probability this is Alice sessions and vice versa. And so this is something that, and we have a talk about this. So this is a very important information to keep in mind. So you have all these kind of things, and we already talked about this. We didn't do anything very specific, but and it's very similar to what we already did. Basically, you have to just and do it by yourself. And so basically, the first thing we need to prepare the data, and we need to transform the data frame so that each like website has the corresponding features and its values equal to the number of the website visit in each session. So this is very important. You are and you are going to create like and such matrix and a sparse matrix that that corresponding features and the values equal to the number of this and website visited in these sessions. So basically this is a gigantic matrix, and the entry that you have is the number of visit of the and the website. So we can, not any, so each session they will visit all the website, and they only visit at the most 10 website. So that means they and the matrix very sparse. And we're going to take advantage of this fact. And then we're going to using this like and the logistic regression. It's basically the same. This is the one of the most important algorithm that we use in machine learning. So basically, we're using the 90% of training, the remaining 10% as a validation to do and kind of like and to demonstrate the validation error here. So what you can do is you're going to write a separate function that like what we did in the training and predictions, that to and return the quality of the model, which is the an AUC number, then also an output, train your classifier, and output the result of validation set and so on. Okay, so because you are going to write unified and the functions, and you can use these functions again and again. So like, I mean, in order to do the predictions and to make the predictions, then you need to train your model again on the entire data set. Then you're going to make predictions. I mean, this is very important. If you actually want to make prediction on a testing set, once you already have your model best parameters, you have to unify all the data and apply it on the testing data set. So one important thing is, okay, so right here, this get AUC LR valid, I want you to write as general as possible. Okay, so that means it can be applied to all the functions in the futures. Okay, so I mean, if you change your features, if you change your like things, you can still call the same functions that you have, right? So I said you will need it to use, you will need to use it in the later of questions. If you don't use it, you will be deducted the points. That means you are not listening to what I asked for. Okay, so this is something that is very important. This just gives you some indication you need to using this subroutine in 1.4, 1.5, 1.6. Okay, so this is very important. And later on, all these like 1.4, 1.5, 1.6, it's all about like feature engineering, adding more features, and the regularization and hyperparameter tuning. It will take a bit of time, but I think my instruction is clear enough. If you have any questions, you should always ask me through emails or come to my office hour. So there are two things that are very, very important. I write everything like, say, discuss your findings. You must discuss of your findings, of your result, your output. And what do you think about this? Can you give any like thought about your results, right? So you need to using your own language to give a conclusion or like summary of your result. I mean, if you don't do that, you won't get full mark. In fact, you will probably deduct most of the points. This is much more important than writing a code because it demonstrates how much you understand the problem, how much you understand the result. Okay, this discuss your finding has to be very, very specific problem. I mean, I saw a lot of discussing findings are very generic. That's not what I am asking for. I ask you to tell me your discussion based on this specific code right here. I need to hear your understanding, not something very generic things, okay? All right, so now I'm going to go through this. This is basically go through this again. I mean, all these feature engineering, feature like selection, all these kind of things. In this part, I already tells you what to do. And by the end of the day, it becomes like just a like pandas practice, right? So I tells you what you should be processing. It's like homework 1. There's some like specific task you need to do. You just do it until you. And I mean, this practice tells you maybe whether I mean this feature is useful or not, something like that. But it's much more interesting that you getting some like baseline and the result from today's lecture and also the question 1. Okay, so that means you have two baseline and the result. In this part, you are going to come up with your own features. Okay, your own explorations. You will need to beat these two baselines that I provide. Okay. There's one thing that I want to warn you that previously, my baseline is based on 10-fold, right? So, and today's lecture, I changed into 3-fold. It's just because of 3-fold is quicker to run. And what I mean for the baseline here, it means baseline for 10-fold. I would suggest you to go back to change the 3 into 10, then you rerun everything. I know it will take a bit of time. It will take about 10-15 minutes to run. Okay, please run it and make sure you keep a record of this baseline. And that's the baseline you're going to beat. Keep in mind. Okay. And also the baseline that you got from and the question 1. So this is some other baseline you're going to beat. I will not provide any step-by-step instructions. So there's a lot of things on your own. This is very, very data science. I'm inspired like that. So you are going to see all sorts of like such kind of problems again. So here are some new tips to find new features. Think about what you come up with using existing features. Maybe trying like multiplying or dividing 2 of that, like feature transformations, right? It's very important. And justify or decline your hypothesis with plot. And for example, and during this EDA, and you have, and we have done a lot of plot, and you can justify and decline these hypotheses based on this. Maybe this can help you to create new features. And also, you can extract useful information from time series data. So you have a time 1, time 2, time 10. We're only using the time durations, right? So this is only the maximum time you have, minimum time you have in one session. I subtract that. That's time durations. I didn't use any information for those intermediate time steps. Okay, so, and also you can convert all these like an existing feature and maybe take the logarithm or something like that. I will encourage you to try different ideas or even new models. You don't actually necessary to using logistic regression. You can try random forest if you want, but of course, random forest will take much longer time to train. All right. Here is the tip, and I will suggest you to start as early as possible. The homework is due on next Wednesday, so you have almost like less than 1 week to finish it. It's very, very important that you start early, and because this whole things will take really long time to work on that. Okay, so that's everything I want to talk about today. If you have any questions, please email me or maybe come to my office if I'm available. All right, thanks.